Welcome to the Rich Report, a podcast with news and information on high performance computing. Today, my guest is from Intel. We have Trish Damkroger. She is the VP and GM of the Extreme Computing at the Intel Data Center group there. Trish, welcome to the show today.
Thanks. I'm glad to be here.
Well, Trish, how long have you been at Intel, by the way? I forget.
You know, it seems like years, but it's been a year and a half that I've been loving life at Intel.
Well, good to hear. So, this seems like this is a new name for your group, is it not?
It is. We have recently merged the technical and the business side of high-performance computing together. Mm-hmm. So I am now two in the box, which is an Intel-ism, I guess, with Al Guerra.
Oh, wow. Al Guerra, the computer architect who created Blue Gene back in the day.
You got it.
Wow.
And is still creating wonderful things here at Intel.
Oh, that's great news. Okay.
It is great.
Okay. Well, Trish, we have a slide deck here. Why don't we go through that, and then I'll probably have a bunch of questions for you after we hear that. So please go ahead. Yeah.
Okay, so today I just wanted to focus on some of the technology trends that we see driving the high-performance computing ecosystem. If you look at the overall compute landscape, you can see that it's changing and it's evolving and it's growing. Basically, it's our light switches and our refrigerators connected through high-performance networks. We have this discussion of autonomous driving, and really that's going to be putting a high-performance computer in your car. I already think we have a lot of computing in the car, but it's even going to get more extreme. We have AI helping us make our buying decisions, and AI is going to get more and more involved as the data continues to grow, and we need AI, machine learning, and deep learning to sift through all that data. You also have differences in the way we are getting our compute, either more and more through the cloud, but we also still see, growing on-prem due to security reasons. So I think the summary of this slide is our compute landscape continues to evolve, and it is also growing, as we can see, with all these new use cases. I'm really going to focus on the HPC market segment because I'm a true believer in the power of high-performance computing, but as you can see, it's a really good business decision. We are up to $500 return on investment for every $1 spent in private cloud, and I think that speaks for why so many enterprises are getting into high-performance computing. You also look at where HPC is being delivered. Most of us are familiar, I'm very familiar with the centralized HPC center coming from Lawrence Livermore National Labs, and that's still, in general, where most of us get our HPC cycles from. We call them private cloud. It's hosted on-site and on-prem. We do see growth in the public cloud, and we'll talk a little bit about that, and talk about why you would want a private cloud versus a public cloud for HPC. Obviously, the two biggest growth vectors that we see in HPC are AI and then also data analytics. When I talk about HPC, I use the Hyperion definition, which is modeling and simulation, HBDA, so high performance data analytics, and AI. And so when I look at that overall growth, we have a very large growth market. You can see with 30% for AI and 17% for the data analytics. But we also are seeing just our modeling and simulation needs growing at about a 4 to 6% rate. Let's talk about the key trends. And it's all based on the data growth that we see across the board. And we see directives in two different ways, both in cloud and then also in new workloads and new workflows. So just talking about data, we have 1.5 gigabytes per day being delivered from you sitting on your laptop, or a drone that's using an average camera is going to deliver 18 terabytes per day, or driving your car for 90 minutes is going to deliver 4 terabytes per day. And you can see just our virtual reality or artificial reality is 3 terabytes per minute. We are creating an amazing amount of data. And I think one of the statistics that's really stuck with me is we are only able to look at 1% of today of all this data, and we're going to have huge growth in the amount of data. And then we talk about cloud directive. So this is one of, so you have this huge data growth, and I'm hearing from a lot of people that their management, the government, the politicians are talking about, you need to move this to the cloud. Here are some just examples of different initiatives of where they've said we're going to be moving a lot of our data to the cloud. The European Cloud Initiative, some of the other more news stories about how people are moving to the cloud. And I think this is really telling because I agree that the cloud has been a way for us to grow HPC, so more people have access to HPC. One of the things that I find with some of the HPC centers is they are overloaded. They are completely full, especially when you go to a university or these smaller sites. And so the only way those professors can get HPC cycles is to move to the cloud. The constant discussion we're having is sizing it appropriately for your key workloads. And what are the key workloads that you're going to keep on-prem versus sending to the cloud? And there's a lot of different elements that you need to think about when you make that decision. So some of the sample workloads that we talk a lot about to our customers are in these areas, whether it's manufacturing, financial services, life services, and oil and gas. And all of these have a reason to stay on-prem and also have some usage in the cloud. So they're a great discussion point we have with our end users about, where to keep the core technology. And you really have to think about your storage requirements. You have to think about your security requirements. You have to think about what is the core intellectual property for your business when you're making these decisions. Right now, 69% of the sites say they're using a private cloud, so on-prem, for more than 10% of their workloads. And they run their most important workloads in a private cloud. And I think that's the key, is you've got to prioritize your workloads and make sure you're driving those to the infrastructure where you have the most security. Now, what we see really growing in the cloud, and you can see this across the board, is machine learning as a subset of AI, but AI in general. And we expect those numbers to double by next year of how much is being moved to cloud infrastructure. And you see this a lot. You'll see that in deep learning, we're looking at quite a bit of increase, as we say, 100% increase, right, in training and inference. We see a 50% split between training and inference, and this is what is really growing in our cloud environments, not so much our traditional modeling and simulation growth. AI, is AI the big hype, or is it really here? And it's really here. I mean, you can see by these headlines that people are using AI. I laugh because whenever you get on to go online shopping, you definitely get recommendations and other things like that. I mean, that's an obvious source of AI. We have a number of POCs we are doing with industries. I love some of the stuff Intel is doing in the medical field, where we are using AI to help doctors pinpoint what would be the best therapies for patients. We're using it in a POC where we are taking in a lot of the patient's data that is in intensive care. So their heart rate, their temperature, blood pressure, and we're now able to alert personnel, emergency response people, sooner because we'll see these changes happening in these basic sensors that we have been monitoring all along. So those are the really good uses of AI that we're seeing. I think we'll continue to grow and just expand in those uses. So it is happening today. As I said, it's going to be a huge growth for even next year. And we need to continue to figure out how to take advantage of that in our traditional HPC space. So that's where I talk about we really see this convergence happening because we see that we're going to be able to answer questions better when we use traditional modeling and simulation, AI, and high-performance data analytics. There's a number of examples where you'll see that these things are being brought together in order to make better models for our HPC and also to speed up the machine learning process. I think a great example is in weather systems, where they've incorporated the data, the actual results with the models to help the models get better, and as a result we're getting more accurate weather forecasting. And that's happening today across the world. So where else is it going to happen? I think this is we talk about autonomous driving, and we will definitely have a high-performance computer in our car if this is going to happen, because you can't just base it on sensors. You've got to be training and learning along the way, and you're going to need to be modeling the different things that are happening to your car. Smart economics, again, when we talk about financial services, it's going to be this convergence between data analytics, AI, and what we're doing today in HPC. Smart factories, same thing. I get very excited when we talk about different materials. Some of the work at Lawrence Livermore was about additive manufacturing. You need to understand the fundamental properties of the material in order to create the part for additive manufacturing, so that you would know, how fast you could extrude it and what was the setting temperatures, etc. I mean, it was just a continual process of taking data in, modeling it, taking data in. It was this great example of this converged workflow. Then obviously in the predictive analytics, again, it's going to be this convergence that is going to drive the insights that will be that next step we need for performance. So when Intel looks at the space, the first thing we need to do to help with this convergence is to create a unified stack, really a resource manager that can go across the bare metal provisioning and then also what we've been used to in more that AI with TensorFlow, those kind of runtime environments. We are working on this multi-domain resource manager, and we're hoping that I'm used to the Slurm world and others are used to these frameworks, that if we put these together, then that all of this type of compute will work harmoniously together on high-performance infrastructure. One of the things that, even though I am a true believer and lover in high-performance computing, some people think we're nerds and a little bit niche. And I believe the infrastructure that we have been developing for the last eons, right? 30 years, SC18 will be the 30th anniversary, is what everybody is going to be needing for the future. They need that high performance infrastructure. They need the low latency, high bandwidth fabrics. They're going to need the memory architecture to support the different needs for AI. We're already seeing the memory needs for AI. that are much larger and the data needs for big data. So you're putting these all together. I believe HPC infrastructure is what's going to be the answer to solve all the problems of that convergence. And so I think we're in an incredible position to help the rest of the compute ecosystem move towards this higher performance, more dense architecture.
Well, great, Trish. I'm starting to get it. I'm a little slow on the uptake sometimes, but why you renamed your group Extreme Computing, because it isn't just traditional HPC with simulation. It's much broader than that, isn't it?
It is. And it's hard to come up with a name. And that's one of the biggest challenges, I think. In the SC community, we have struggled with this.
Yes.
For a long time. We have a tagline, and we have this debate, I'd say, every 2 to 3 years. Do we want the tagline to be fully inclusive? How important is it? Where is data in that tagline? Where is AI in the tagline? That is a continual challenge because the use cases for the high-performance infrastructure continue to change.
Yeah. And Trish, you coming from, the government sector at Livermore, which you mentioned earlier, I mean, I could see they need these capabilities as well in addition, don't they? I mean, the big data analytics and the AI to deal with all the data they crank out of those big machines.
Excellent. Yes, excellent point. I would say that they at Lawrence Livermore were definitely driving AI and high-performance data analytics when I was there 5-10 years ago.
Yeah. So Trish, kind of a wrap-up question here. You spend a lot of time with customers, I imagine, and what are they asking you for besides a faster chip? Is it help to wrangle all these new domains?
I think that they have what we have been talking about, some of the challenges that we're facing as we continue to put more and more performance into the chips. We still have power as one of the barriers. I still talk to a lot of people that say, I have to fit this within 4 megawatts, and how much can I get? Lots of discussion about programmability. We're lucky at Intel that we have an incredible ecosystem built up on the x86 architecture, but they still want more and more performance out of those chips. So how do we optimize Xeon to continue to deliver the performance that our customer needs? I would say those are the two biggies.
Yeah. Well, Trish, this has been fascinating. I'm looking forward to hearing more from you and Intel. I understand there's some new Xeons in the works, but maybe we'll save that for a future show.
That sounds wonderful. I can't wait to tell you more.
Okay. Well, thanks for coming on. All right, folks. That's it for the Rich Report. Stay tuned for more news and information on high-performance computing.